everyone. My name is Bardia. I am representing AWS RDS team. So we prepare database services in AWS cloud. And for this presentation, I'm presenting the tool that we recently worked on. And so basically the tool is about, just please let me know if the presentation is visible in the screen.
Yes, it is.
Of course. Okay. So we call the tool the Upstream Pilot AI tool, and it is meant for helping the open source developers who are contributing to MariaDB server. And just a little bit of background. I have a PhD in simulation and control and a Master of Science in Computing Science. I worked in the industry for the AI for at least 5 years now, and I recently joined Amazon. So we recently embarked on a project called Upstream Pilot. This project aims for helping the developers. So a little bit of overview would be, I go a little bit of background of any information that we would need during the presentation. We have 3 development phases for our tool. And so the first one is the single agent workflow. The phase 2 will be assisted multi-agent workflow. And the third phase would be an autonomous multi-agent workflow. We also have some showcase progress so that we show you the current progress of the development. And we also had a hackathon day at Amazon in our team. So we use the tool to contribute to MariaDB server. So a little bit of background. You have heard this name, large language models, or LLMs. So these are powerful machine learning models that they are capable of understanding, generating, and manipulating text-based, based on text-based training data. And they help us in a lot of ways. One of the famous ones is GPT from OpenAI. We also provide Claude through Amazon Bedrock. So the principles is based on transformer architecture and attention mechanisms, and it's based on very vast text data sets. That is how it is trained, and it can also be pre-trained for specific topics or fine-tuned to specific purposes. So the applications are for large language models: code generation, debugging, documentation, NLP or natural language processing. And there are also some, of course, limitations with large language models. Sometimes they hallucinate because they try to guess based on probability what the next word would be. Sometimes it is prone to hallucination, context limitations. So they usually have a context window and some limitations of how much they remember from the topic, and sometimes they are limited in the token size and a context window. And it relies on large computational resources to train them and, of course, using them in production. We have another topic called retrieval augmented generation, or RAG. So RAG is trying to help the large language models to have access to external resources. And so it basically combines retrieval mechanisms with LLMs and helps to generate more accurate results, assuming that, for example, one of the very basic examples is that assuming that the large language model was trained based on a 2023 data, but we are asking who was the winner of the World Cup very recently, but they don't have the data. RAG gives the ability to the LLM to retrieve the data from other resources. So basically, although it doesn't have that data in its own training, it can retrieve that data from internet through various APIs. So the importance is that it helps LLMs generate contextually accurate context and up-to-date responses. Precise code generation and problem solving are other important features of RAG. So the components of a RAG are the retrieval module, which searches for relevant content, and there is a generation module, which retrieves the content to inform the responses. So some of the example cases are document retrieval. For example, when you have a vast corpus of text, and if you want to search or even talk to a book, for example, if you have a series of documentations and you just want to chat, just want to have a chat with the chatbot and ask questions about that text. So that is all possible through RAG. So other example use cases are historical resolution lookup, contextual enhancement, and other features as well. So the benefits is that it reduces the inaccuracies in the large language model responses, and it makes them more reliable and increases the user trust. Another topic I would like to introduce is the model context protocol. As you can see, as an example on the right, you can see the with and without MCP implementation, how the API calls work through the LLM. So it basically unifies the API connections to LLM through various, for example, is it through a Slack, is it through a GitHub, or Drive, or other services. So basically, MCP is a protocol designed to enhance the throughput, transparency, reproducibility, and tracing of AI-generated outputs by bundling all the data, during the generation. So the purpose is to we can audit the outputs, and we can understand human reviewers or downstream applications. Some of the examples are like the ones that some plugins that we integrate into IDEs, like CI/CD pipelines or other aspects of it. The benefits of using MCP is that it increases transparency and improves reliability in automated solutions. Another topic is multi-agent systems. So a multi-agent system consists of various agents that they try to collaborate to solve a complex problem. And they try to divide the task into specialized roles for each one, and then they try to resolve the overall problem together. So the core concept consists of the agents, the environment, the interactions between the agents, and the collaboration mechanisms between the agents, and specializations of the tasks among the agents. Each agent would have a role, and so they have their own task assigned to them, and they try to resolve the issue on their end. Agents are used for retrieval the retrieval aspects, like gathering context, for planning, for coding, for debugging, for reviewing, and etc. The advantages of using multi-agent systems is that task specialization leads to higher efficiency, and it helps increasing the scalability of the solution. Similar to RAG, we can horizontally scale our solution when we have a higher load. And some of the practical examples are automated ticketing, issue resolution, and collaborative coding. So here we get to the first development phase of our app. So basically, our app tries to help the developers to pick the Jira tickets and analyze them and suggest a solution. We are currently at phase 1. In this phase, we have implemented a single agent workflow, which can be seen. The schematics can be seen on the right side of the slide. So right now it's a serverless architecture. It uses AWS Lambda orchestration to look into the knowledge base, and the knowledge base is based on OpenSearch, and it knows the code on that MariaDB server uses for the implementation, and it uses Bedrock to interact with the LLM model, and then it tries to retrieve the data. And the data would be, so sorry, something, yeah. So the data would be used for as an output to the user. So the functionality is that the centralized Lambda function, which tries to orchestrate the whole process, it acts like a router that directs the requests based on API calls. For example, it tries to rank the Jira tickets and etc. We have data storage and retrieval. So we have caching systems for quick responses and also local. We also save them locally. I will show you during a live demo how it works. And OpenSearch, as I mentioned, works as a knowledge base that is used for, it knows the documentation of MariaDB, it knows the code, how it was developed, and how the solution works. The next aspect of the workflow is the AI integration. So AWS Bedrock, as I mentioned, enhances the core processing. We can have access to many different LLMs and many different AI and generative AI services through Bedrock. And we have external integrations with Jira to scrape the Jira pages and retrieve the information of different tickets. In the second phase, we will focus on multi-agent workflow. So assuming that we have start from the problem definition, we analyze and prepare some planning suggestions for example, plan 1 to plan K, and then we rank those plans and we assign each to one agent. For example, one agent would go for coding, the other one goes for debugging, the other one creates the unit tests, and we always have the human in the loop as a reviewer. If the generated code by the agents makes sense before submitting them to the Upstream, which would be the MariaDB server foundation. So this is the overall workflow. For example, on the top, you see that it starts from the problem that the retrieval agents works on it, then the planning agent, the coding agent, and the debugging agent works on it. So the retrieval agent performs the contextual analysis of Jira tickets. The planning agents generates multiple confidence rank action plans, and the coding agent transforms those plans into executable code. So there are program-aided language frameworks or PALs that we can use for generating the code. Debugging agent would use advanced state checkpoints and debugging whenever the code is prepared. And the review agent would automate the code review. Of course, it takes feedback from the people who are just supervising the workflow, and they gather the feedback whenever necessary. And the MCP export agent would do the packaging and traceability of contributions. And with regards to integration, we would use, for example, Lambda, Bedrock, OpenSearch, and step functions and other features inside AWS cloud. So the benefits are efficiency gains that we get out of this workflow, because it allows the developers to concentrate on the core concepts of the code, and will help them speed up. We will have consistency. We have reduced cycle times, faster resolution of Jira tickets compared to phase one, which is just a single agent that tries to just give some recommendation to the developer. We will have improved review process and enhanced developer experience. And the key benefits, as a summary, are higher productivity, reduced errors, quicker contribution cycles, and higher quality outputs. So in phase 3, we will focus on autonomous multi-agent systems. We try to reduce the human in the loop aspects of it. And so basically the agents would work like developers and more or less like humans. So in this case, we would use, similar to phase 2, reinforcement learning, which the agents improve their decision-making strategies based on the feedback that they get from already gathered, or they are also sometimes asked about that feedback from the reviewers again. But it would be in a less communications between the supervisor, reviewer, and the agents. It will take the solution to its near final aspects, and then it asks for more more feedback whenever possible if the reviewer rejects the code. We have meta learning that tries to adapt agent behaviors to handle evolving tasks. And I also talked about human in the loop fine tuning for specific features, for example, security aspects, different aspects of MariaDB contributions. Adaptive operations, which we use for continuous updating of implementation plans. And the benefits of this workflow would be to reduce the intervention of the developer, continuous adaptation, and higher accuracy and reliability. With this regard, we will have enhanced contribution capabilities, and we can have more collaboration and efficient open source development, and we would try to increase the number of contributions to Upstream. And the long-term objective is to transition to a fully autonomous system that tries to rank and tackle problems. And of course, at the end, it will be reviewed by the humans. This is the overall look of the tool. So I will also show on a live demo how it works. So basically, whenever you open a Jira homepage, it will show you a drop-down menu, which right now is chosen to be beginner friendly. It's based on the labels we have on the Jira tickets. This one, it retrieves 5 latest Jira tickets under that label category and shows the top 3 results. So one of the example of the results is shown on the right. So it shows the difficulty, the impact of that Jira ticket, a short explanation, and the description, and the required knowledge based on as keywords, and the estimated time to develop that solution. So once we choose one of these Jira tickets, we will have different buttons to analyze and suggest solution, which we will go over one by one. And one of the examples here is showing the analyze result on the left, that it basically tries to analyze the Jira ticket in plain language, adding more context to it. And then it will send it to our the knowledge base system, and then the LLM based on the RAG implementation would work to come up with a suggested solution based on the MariaDB code base. So we had this hackathon day at Amazon YVR office in Vancouver back in April 2025. So 6 developers worked on in an isolated environment to contribute code to the MariaDB Foundation. And so we used the Upstream pilot bulk ranking. So what I showed you just previously was just a limited number of Jira tickets. So during the hackathon day, for each label, we gathered around almost 100 latest 100 Jira tickets under each category. So the developers had access to all of them to see how they pick their Jira tickets based on their difficulty levels and their time limitations, and analyzing and understanding the Jira tickets using the same tool, and implementation and testing based on the suggested solution of the AI tool. During that day, 4 developers submitted their contributions by the end of that day, and the remaining 2 continued in the subsequent days because of their workload. In the earlier stages of our development, because we are still in phase 1, it helps us reducing picking the Jira tickets by 70%. Average time for analysis and suggestion usage was 3 hours to develop the code, and 1 to 2 hours to design the tests and MTRs. Here is the list of the Upstream contributions, which some of them were already pushed to the MariaDB server. The other ones are pending approval for AWS internal. Pending approval in Amazon, and then they will be pushed very soon to Upstream for getting feedback. At this point, I will quickly show how it works as a live demo. So it has right now a beginner-friendly issue label, like a security issues, performance issues, documentation, and custom search. So custom search is just a filter that we define based on some criteria that will pick any other label that was not listed in the above mentioned labels. This is how it looks like on the homepage. So you would install a Tamper Monkey script, which is like that, and you add the script. The script would connect to the API gateway, and we would use the Amazon Bedrock implementation right now. And then for example, you can click on any of these Jira tickets that they were ranked based on their difficulty and impact. Of course, we have bulk ranking. This UI is not showing the bulk ranking, and because it may expand to 100 Jira tickets, and that's too much. So once we picked one of these Jira tickets, we go here this is, for example, the one that I worked on during the hackathon day. So I picked this one based on the difficulty level, and it was about creating the Oracle compatibility for and creating the init cap function. So if we, it basically has 4 buttons. The first button is to analyze the Upstream, analyze it with Upstream Pilot. And once the analysis is done, because it takes a few minutes, one or 2 minutes, in order to reduce the time, being more efficient, we can also reopen it anytime we want. So if I reopen it, the basic ask was to create the init cap that Oracle has and the ask is to create it inside MariaDB as well. So as you can see, the original ticket has just this much information, but when we open it with the analysis tool, it even gives you examples and more aspects into the problem. So it shows the a summary in more detailed and the technical constraints of it, potential impact areas, complexity assessment. It says it's a medium-low complexity. And the relevant background information that someone wants to implement it for, they need to know how to use the upper, lower functions, things like that. I also produces some keywords at the end to summarize the whole picture. When we look into the, once the analysis is done, we can click on the suggest solution. And since I already clicked on it and the solution is already there, I don't want to take some time to process it again. If I reopen it, it shows you that you need to implement the function. You need to change the item underscore str function.h. You need to implement the init cap inside that header file, how you need to implement it inside the item str function.cc file. And it even shows you a rough implementation and so basically the overall solution. So when I looked at it, when I was doing the hackathon, it helped me to see which files needs to be changed and almost how it should be implemented. Of course, I changed it a little bit, but it was a good starting point. And it shows that it needs to be registered in item create.cc and some other examples of how we can prepare the MTRs and what the expected solution should be and how the MTR should be implemented. It also tells the developer to take care of the Unicode strings as well in the implementation, and just some edge cases like null cases and things like that, and some of the edge cases as I mentioned, and more information, of course, which was very specific to this ticket. Thank you so much. I mean, it was a long presentation. I really appreciate you guys listening to my presentation. I'm here to answer any questions.
Hey, Maria, thanks. Really good presentation. So let's first have a couple of applause. So questions?
Yeah. So how about the performance? I saw all the agents, but not a single one was doing performance. And some of the AI models can answer a question, but they never actually compile and test the code. Can you have agents for doing that also and doing performance comparison with different solutions?
Yeah, of course. So in terms of performance, we can have different criteria to measure the performance, like how much time it takes or how much resources they are using. That would be definitely in the plan. That's a really good point to take care of in the multi-agent development. For now, since it was a single agent, it was just one plan out of those K plans that I mentioned in the presentation. So it is only following just for one plan. So it's nothing to compare at the moment, but of course, for the more when it comes to the second phase development, we will have that in place.
I also noticed that the generated code didn't follow our coding standards. So which was a little bit surprising because it was actually looking at our code.
Yeah, because as I mentioned, we need to have a debugger agent. So the debugger agent would take care of that syntax that needs to be inside MariaDB, for example. I know the coding standards that we have at MariaDB server foundation. So that is one of the things that the debugger agent needs to take care of.
Yeah, but otherwise, very nice presentation. Thank you.
Thank you.
So I have a question about the generated content. Maybe I missed something in the presentation, but how do you verify that the content is correct? For example, the code or even the other hands. So sometimes is reminder they are good enough, because I use ChatGPT a lot for generating content, and especially sample source code. So I think what I do explicitly is to verify whether the code generated is correct or not. So in this case, is there any step for that verification, whether it's source code or other content?
Yeah. Thank you so much for your question. That's a really nice one. In the three phases that I introduced here, for the first phase of the development, there is no feedback to the agent at the moment. But when it comes to the multi-agent, and even for the single agent, it can be implemented. That once the code is done, we give a feedback to the agent that and evaluate the output code. Of course, whenever we use LLMs for generating code, they may hallucinate for the solution. One of the reasons we use the RAG implementation is that we would try to reduce the hallucination during the process. But at least in the first and second phase implementations, phases of the implementation, we will have human in the loop directly working with the agents to improve their actions. And in phase 3, whenever the coding is done, for example, overnight, it needs to be verified and approved by a reviewer. And then if the code is good, it will be sent to Upstream. But if not, it needs to get another feedback and instruct the agents to work more on how to prepare the final better code. That is one of the reasons we use human in the loop and reinforcement learning using human feedback, of course. Yeah.
Okay, thank you.
Could you show the generated code again? I was interested about one thing. Okay, so the str_alloc rest length is wrong because the string can be longer than when you change a small character to a big one.
Are you referring to
down? Str_alloc.
Oh, okay.
There's a str_alloc down. That one. So the most efficient one is basically to ask the character set is what's the difference in length between small characters and big characters, or maximum, and then you need to multiply the length with that one divided by 2.
Mm-hmm. Yeah. So this, as I mentioned in the first phase, the generated solution is not the final product. It's just right now is an.
No, but I'm just saying it's rather good. I'm just saying that it did miss one little thing.
Yeah. Yeah. So but it can be served as a starting point, at least for.
Yes.
Yeah. Yeah, you're right.
Hello, I have a question. Thank you so much for the nice presentation. I have the same question in the continuation of the discussion that we have. My question is specifically related to the reinforcement learning. So as you mentioned that you have multiple agents that are there, and right now you have basically presented with one agent that have a ranking. So my question is whether there is any kind of collaborative mechanism that you are considering while each of the agent can just try to communicate with the other agent before involving human in the loop. That is the first part. And the second thing is that when you're considering the reinforcement learning, so for making those kind of policies functions, are you taking help from the LLMs so that they can help you to create those kind of policy functions? Thank you.
Yeah, basically, thank you so much for your question. I mean, those are really good questions. So, regarding your first question, you're talking about agents talking to each other in the reinforcement learning. We need to finalize the design to a better of course, architecture. We need to look into see if that would help us develop that phase by, the agents also talking to each other in terms of the reinforcement learning aspects. That's why we also introduced meta learning to learn from the past and from the past actions. Could you just repeat your second question?
Yes, because I think the first question, maybe you misunderstand it, but my first question was because you have mentioned that you have multiple agents, right? And each of the
Yes.
agent is passing the request to the second one. So
Yes.
based on that, and then you represented that you have like the ranking mechanism where you're just trying to ranks the whatever information we have, right? And then you have mentioned that there is a human in the loop that is involved, and it's basically making a decision that whether the agent is performing good or bad, right? My question is that with that kind of thing that you have, because usually when we are using reinforcement learning, so we are using before that human is involved, we have to make sure that the agent first collaborate with each other, try to come up with a solution, and then based on that solution, if that is not optimum, then the human has to make a feedback. So I was
Yes.
thinking that whether in terms of that, how the LLM is supporting you in this kind of solution.
Yeah, so with regards to that, whenever the problem is defined, the goal in the second phase is to generate the unit tests and the MTRs and making sure that the human is involved whenever this at least one final solution is achieved. For example, the unit tests are passing, and what it happens to have like two plans, and it has proceeded with two plans. It came up with two solutions, and the human is involved to see whether the final solution is actually providing the results that was asked for, and whether it passes all the MTR tests, or maybe all the MTR tests that were introduced, maybe the agents work together and find some MTRs using the LLMs and do not consider, in this case, the Unicode structures. And the human thinks that it needs to be there. So once we finalize the feedback, we pick, for example, the best solution out of two, and tell the LLM agent to tell the agent to use the LLM to evaluate that, and to use with the implemented reinforcement learning module, it tries to improve its performance. So it first, some of the aspects are whether it is providing the solution requested in the Jira ticket or not, whether it passes all the MTR tests or the unit tests, whether it is updating all the necessary file requested, whether the code can be run or not. So all of these can be a feedback that can be sent back to the agent, whether it is working fine or not. Does that answer your question?
You said yes. Thank you.
Yeah.
So, Badia, you were mentioning MCP there. Do you already interface MCP with, or you're not using MariaDB for like you do not need to interface MariaDB with MCP because you're using MCP for other purposes than the vector storage of MariaDB, right?
Yeah, for example, MCP can have different use cases. We can also use that for interactive coding, especially in phase one, because we are not done with phase one yet. And we can have that integrated into VS Code and just like a chatbot helping the developer to prepare the code as well. So right now, MCP has not been is in the progress, is not being finalized for phase one, but that is definitely in the plan. One of the things that we need to integrate into our Upstream pilot, of course, is an MCP. But since we started just 1 month ago, we haven't got to that point yet.
So there was a specific reason I was mentioning MCP because there is an MCP interface to MariaDB Vector, which is probably not applicable to your case. That was submitted as part of a hackathon this Monday. So you will see more published on that later on this month. That was an FYI.
Nice, thank you.
So what's the next step? It would be nice to have all this AI interfaced directly in our current Jira. Is that something that we can get done to help other people produce more code, or is this just something that you will have yourself?
No, it will be. The goal is to increase the upstream contributions and encourage everyone to contribute to MariaDB.
So this analyzed with the Upstream pilot, is that already in our Jira?
Right now, at the current production stage, is that you need to have the Tamper Monkey script, as I mentioned here. So it's one of these Tamper Monkey scripts that needs to be copied over to everyone.
Sergey, this is for you to implement.
For now, it's internal, but later we will publish the Tamper Monkey scripts as an open source code so that everyone can use it, and they just need to talk to an API and just talk to the server, and they can use one of the already analyzed or suggested solutions, and they can just reopen it and see the potential solutions that they want to work on that just specific Jira ticket. So the answer is yes. The goal is to make it public.
Yes, so Monty, we were interacting with Badia last week about this, and we had very much the same question.
So one question also about the capabilities of the system. So the LLM, is it trained on all the MariaDB code that you are?
Yeah, so the MariaDB, so the knowledge base will have different metadata associated with different versions of MariaDB. So we can have, right now, the knowledge base is based on the latest version of MariaDB server code, but it will include different versions of MariaDB. So if the Jira ticket is specific to one specific version of MariaDB, it needs to retrieve that information from the knowledge base. Right now, it's based on the latest code, but that is also something that we will have.
But fortunately, we don't do really lots of code restructuring. So having the latest code, it actually probably other part. So that's good. The other question I had, you also had a task about MTR and change owner, change user. That's a little bit tricky because the MDev didn't explain that you need to change the MySQL client code. It's not really in MTR, it's in the MySQL client. So how did the LLM manage to find that out? Or did it find that out?
Whatever you see in the solution suggestion right now, Is based on what we have a concept in LLMs that we call them zero-shot prompts. So zero-shot prompts, they are kind of open-ended. I mean, an open-ended solution to a problem. Sometimes it is prone to, if it is giving you something that is out of the context or it is not necessary to do, or because right now it already knows every single line of the code in MariaDB server latest version. If it gives something out of the context that doesn't have to be there, it should be noted out by the reviewer and fed back as a feedback loop to the LLM agent. So yes, if it is something extra, we need to take care of it. But whenever it comes to more extensive solutions, maybe it is prone to, it is always prone to hallucination. Even with current versions of code generation bots, they always have something that may not be the best. And most of the companies right now, even they have, when they have bots working on a Jira ticket or any ticket, next morning somebody needs to go and review and see if the bot did a good job or not. And it will evaluate you whether it was, it will evaluate the solution with you. And you need to give some feedback, a review to the agent to see if they perform the code generation well or not. So it's not always perfect.
Yeah, actually, my question was more that can you show us the MDev for the change owner in MTR, printing that one? I would really like to see what the reopen suggestion was.
This one?
Not this one, but the one with the MTR and change user. That was one of the other ticket that somebody was working on.
Okay.
I would like to see how good it was to actually find a problem, because the MDev was not good enough. The code change user, that one.
That one, okay. But the thing is, sorry, let me see. Is that the one?
Yeah. Okay, it says that you should change MTR process. That's okay. So it uses that function. Okay, I actually thought that this was implemented in the MySQL test suite.
Mm-hmm.
Isn't the change user done in MySQL test, or is it done in MTR? Yeah. So that So this is it suggested the wrong function to change.
Yeah, it could be.
But it says MySQL test there. Okay, I'm a stupid reader here, but it does say MySQL test.
MySQL test lib MTR process. So MySQL test.c is a program.
Yeah, that's completely fair.
Yeah. So the other one, it did pretty good here. It did do the wrong thing, but that was actually because the MTR, actually Jira ticket, was not really clear of where the change should be. So I changed that. I think that just improving Jira ticket, it could do a much better job. Okay.
Okay. Yeah, definitely. Yeah.
You then, who implemented that? That is, Jira was what?
No more questions for me. Thank you. It was very helpful.
Sorry, I do not have the
Oh,
voice.
sorry. Yeah, I passed the phone over.
No more questions for me. It was very helpful and get me to understand more about both the limitations and the capabilities. So it was good actually that you showed both.
Mm-hmm. My pleasure. So as I said, this phase is not expected for the suggested solutions to be the best solution at the moment, because it's just a starting of the phase one. It will get better. It will get better down the road. So for now, it's just the main highlights was how we picked the Jira ticket and how we use it to analyze the Jira tickets. But it's a suggested solution. It's a work in progress. We did not even expect that to work well at this stage, at least.
So, Maria, do you have any expectations on us, on MariaDB Foundation or MariaDB PLC people at this stage?
We will announce it later, but for now, I think we are just finalizing and rethinking about the overall design of, and we will share that with you in our bi-weekly meetings, of course. For now, I think everything needs to be shared was already published, and I think we will appreciate that down the road if you could help us make it work better, of course.
The MariaDB Foundation is the global contact point for collaboration on MariaDB server. Our work is made possible thanks to the support of our sponsors.